This is my final build for the Mazebot project. As you can see here, I have the two motors on the front two wheels there. And then we have two wheels on the back that are just going to be following the same direction as the one ahead of them. We have two motor controllers, one on each side for the two motors, and they are going to be in pins number 31 and 32 on this motor section. And then we have a push button on the front of the bot, which is going to be plugged into pin number 2 of the digital inputs. I have the battery holder on the front of the bot because before I had the two motors on the back two wheels, but I found that the front end of the bot will come up, especially on the ramp over there. The front of the bot would come up, it would throw off direction, so I put the weight of the battery on the front to hold it down, but then I later moved the motors to the front two wheels, so it didn't really matter, but the battery holder could still stay there. I have these two standoff rods for the push button attached to the front of the battery holder so that the button could have enough clearance to make good contact with whichever wall it's hitting. See, it's much farther ahead of the wheels. And yeah, that's about it. We can go ahead and get into a test run. Looking back at the code, we have our defines for the LCD screen, and then all of the pins here on the liquid crystal. These are all options we used from a previous lab that I just took and put into this code for the same purposes of using the LCD. And then we established the functioning variables, which is the servo left and the servo right. And then we have our push button. And then we have another variable called maze. Maze equals 1. That's going to be used for when the entire maze is complete and we just want to stop the bot. Now moving on to the void setup, we have the left motor attached to pin 31 and the right motor attached to pin 32. Both have a minimum of 1000 and a maximum of 2000. Then we have our pin mode for pin number 2, which is the push button as an input pull-up. And then we just went ahead and defined the push button as pin 2 digital. And then serial begin 9600. Now it's time to initialize the LCD. So these are options, again, we've used before. And then these as well, I just changed, we still have ACC mechatronics, then project Mazebot, and then the status is on the third line. So status of the bot. Now moving on to the void loop. This is where we're actually going to be reading the values of the button and then completing operations. So I have a 2-second delay after I hit the switch. So I hit the switch, get into position, and then after 2 seconds, the bot will begin reading. So we have the button value equals a digital read of the push button. So like button value would equal 0 when unpressed. So while button value is equal to 0 unpressed, the left motor and right motor will both move forward, and it'll say it's moving forward. And then right before we leave the while loop, we want to read the button value again, so that if the bot hits a wall, the button value will then become 1, and this while loop will exit and we'll move on to the next step in the code. The next step would be a wall detected, and the bot will stop. We have a short delay, and then we will reverse away from the wall for a short time, and then stop after the reverse, and then allow the bot time to turn left, and then we'll stop again. And then after that, we're going to read the button value again. Once the bot realizes that the button value is 0, then it'll move forward again. So both left and right motors are activated, the bot will say forward and move forward. And then before leaving the while loop, so it'll move forward all the way until it hits a wall. That's important because this will keep moving forward. It's doing exactly what I want. It's moving forward until the button value is 1. So we'll read the button value again before the while loop is ending, and it'll realize that the button value is now 1 again. Say wall detected, reverse, stop, allow the bot to turn right, stop again, and now we're going to go up the ramp. So we want to read the button value again, realize it's 0, and continue to move up the ramp. Read the button value again, realize we've hit a wall. The bot will then say wall detected and stop the car. And then reverse away from the wall, stop, turn right again towards the last wall, and then read the button value again, so it's 0. We're going to move forward towards that last wall, and then once the button value is 1, say wall detected, reverse away from that wall a little bit, stop the bot, and then it'll say maze complete while it's turning 180 degrees. So it makes that 180 degree turn and then says maze complete. And then this is how we stop the bot after that maze complete. So while maze equals 1, and maze has always equaled 1, we're just saying while maze equals 1 at the very last part of the code, we're going to stop the bot. So, you know, as previously defined up here in the code, we had maze equals 1. So maze has always equaled 1 this entire time. And we're just saying while maze equals 1, the bot will stop in the very last process.